Hey guys, John Smith here, and today I want to talk about some integration you can do with RevealX and a platform called MISP. And what that stands for is Malware Information Sharing Platform. What MISP is it's a series of different open source feeds that are curated by the security community, and they're very, very effective. I'm actually very impressed with this. I've been pretty spun up on it. So it's a great resource to get high fidelity threat intelligence. You can also import your commercial feeds. So if you have something from Recorded Future or CrowdStrike, something like that, you can import a feed via JSON. So it's really a great way to sort of cache this nice set of threat intelligence into a centralized location. Now the RevealX platform can take, up to a little over 1 million observables through a sticks feed. But it can be very valuable. This has several million observables readily available here. And while we can't look them up, constantly do REST API lookups on it, what we can do is pick specific sets of criteria. And using that criteria, that may result in maybe, let's say, several dozen lookups an hour or even several dozen lookups a minute. That's not going to overwhelm your API, right? And that's not going to get you, it's not going to get your API canceled by your vendor or anything like that, right? And I'll talk about what some of those are here in a second. But basically, MISP, it's really good to know your way around it, especially if you have EMEA customers. It's very popular in EMEA. But knowing what this platform does will give you a lot of credibility. So we're going to look at a couple of specific events. So I have this giant repository of threat intelligence. And here I've got event 1383. This is from VX Vault. This is a curated list. Looks like this guy is, so here a few days ago, we've got some threat intelligence here. So let's look at the trigger that we're going to use to do a MISP match detection. So here, and what I mean by not making too many requests is that you should set some criteria so that your requests are, let's say, in the dozens per minute or dozens per hour versus sending thousands of them, right? Obviously, I can't look up every single website against that REST API, you'll overwhelm it. But what I can do is set criteria to keep the number of requests down. So let's talk a little bit about what some of the good criteria is. If you look here, I'm actually doing a match on if it's an external IP and it ends in PHP. Let's be honest, PHP is kind of the whipping boy for web shells, that kind of stuff, right? So, I tend to raise my eyebrow at anything external that ends in PHP. Now, while the majority of the websites that end in PHP are probably just fine, the truth is there are a lot of bad ones, right? So what I'm going to do is if it's an external IP and the URI ends in .php, I want to flag that. The same with executables, right? You can't fire an alert on every single executable because on Patch Tuesday, those updates come down as .exes and you'll get 60,000 alerts, right? But what I can do is maybe say if it ends in .exe, then I just want to check it against my vast threat intelligence archive, right? In the past, we might send all of these to Splunk, and then the SOC analyst would go through the thousands of logs and try to parse out which ones match up with threat intelligence. Well, here what we're doing, because we're using RevealX NDR, is we're going to actually just find out within probably less than a second whether it's got a threat intelligence match. Then that can be sent to a SIM or to a SOAR like Demisto, something like that, right? So that's one area where you can get some higher fidelity, findings without the burden of parsing and sifting through all of these. So what we're going to do is if it ends in .php or .exe and it's an external website, then we're going to ask MISP, do you have a dossier on this? So let's pick one here first. So here, this one ends in a .exe. So I'm going to go ahead and grab this thing. All right. And then I'm going to come over here. Don't do this from your Windows box, right? But here, I'm going to try to download this. Hopefully the site's still up. Dang it. Let me see if I've got another one here. So luckily, That might actually check because it is a web request. So let's see if this comes through. And if not, I've got one canned in here that I'll try. But let's walk through what happens, right? First, we're going to go ahead. Okay, there we go. Okay, so this one did come through. So on this, then on the remote response, what we're doing is we're waiting to hear back from MISP if there's actually a dossier on this. So if we look here, we see, here's the participant, there's the URI right there, and there is actually an event associated with event 1383, right? So we actually do see this event coming through. So we trigger the detection, but then we do something else. We actually post a citing. So what I like about this MISP platform, what it does is it allows you to share with the rest of the community that you're working with that, hey, not only is this particular observable, a threat, but I've also saw it in my environment, right? So think of it as kind of like a police blotter as a suspicious character, right? So we trigger the detection, but we also issue a post to the sightings. And if you look here, you'll actually see the sightings JSON blob that gets sent to it. So if we come back to our MISP 1383 here, this one I can, this will take a while to refresh, unfortunately. Oh no, that went through fast. Okay, good. So here, you actually see here on the activity, we actually have a sighting that showed up. Same with this guy here. We had a couple sightings yesterday. So we are doing two things. We're asking MISP, do you have a dossier on this URI? But also if we see it, if we observe it in our environment, then we share with the rest of the community that we've actually observed this. This is a manual process in for a lot of people using logs. Here, if you notice, the entire thing takes less than a second, I think, to accomplish, right? So that's, let's see, we have 1432, and literally, yeah, so it was less than a second we report the sighting. So that's really, really powerful in terms of how we share data. And also just, it's not that the SIM isn't an innovative solution, it's that we're doing it with RevealX materially differently, right? We're not depending on writing a log, going through and reading it, and then sending reporting a sighting. This is all happening in an automated fashion. And this could really revolutionize the way we share information because we're able to automate it, right? This is high fidelity. We know that this is a problem URI. We know we need to investigate this host. And we know that now which sites, in fact, if I wanted to, I could import this entire campaign into my threat intelligence. And now I'm actively looking for anything related to this campaign. I could import all of these IOCs in. So the next thing I want to do is a DNS one. So another high fidelity check is DNS queries. Now, obviously you can't do an API call against every single DNS query. You will, if you have a commercial API, they will kick you off, right? I've had to beg my way back to use APIs before, but you can set criteria. So again, here, if you look, I have a set of unique names. Now I'm able to do this. This could be a high impact. This could be in a high impact search, because if there is a DGA exfiltration, it will be a lot of API calls. But in this case, my MISP server is local, so I control who accesses the API. But here, I see I've instantiated the DNS names that are common. You could also put top-level domains. So that's probably a much easier search where you can instantiate, the spam house malicious top-level domains, and then anything that has one of those top-level domains, you can ask MISP or whatever your threat intelligence feed is. Hey, is this a malicious domain? So I'm doing two things. I've set the domains I expect to see. Anything that doesn't match those .com, .org, .net, or .uk, I want to check against threat intelligence. But I also want to look for anything with 4 consecutive consonants. One of the things that DGAs seem to be unable to avoid is 4 consecutive consonants. Now, there aren't a lot of words. I would say less than 1% of the words in the English language involve 4 consecutive consonants. We've used Shannon's entropy. and it makes for a really cool looking trigger. But you have to sort of pay that tax because you have to run that function. Running that function on every DNS query is pretty expensive. We do it flawlessly, but I want to, why use the trigger heap when you can avoid it? I find that 4 consecutive consonants is extremely accurate and does a great job. In fact, let's look at them. If we look here, you see it's almost impossible for them to algorithmically derive a DNS name without there being 4 consecutive consonants. So here, I'm going to go ahead and grab one of these. All right. And I'm just going to do a quick NS lookup. So I'm going to go to the bottom here. From the same Linux server, I'm going to do a NS lookup. And I'm going to look this guy up. Let's see if we match our criteria. 1, 2, 3, no, but then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's to my point, you can use Shannon's entropy. It's a great way to look for DGAs, but for whatever reason, it's really hard. You won't get all of them, but you'll get enough that if it's an exfiltration, I bet you get 99% of them if you just look for 4 consecutive consonants. So if you look at this regular expression, I'm basically excluding the vowels. If I get 4 in a row, I'm probably going to check against my threat intelligence. And while any of these could be excessively noisy if we fired an alert on every one of them, again, the goal here is to deliver high fidelity results by checking it against your threat intelligence feed. So I'm going to go ahead, and I did get an NX domain. The thing you got to love about UDP is that it should actually work. So, and I've got some other ones in here. Let me see if I can get one. Let's see. I'll do a few more. All right, that one. So it looks like they've bit bucketed these guys, which is pretty good. It's one of the reasons I think that the MISP is pretty credible, is that these seem to get black holed pretty quickly. So again, looking at our DNS, we're going to check if it's a non-standard domain, and we're also going to check if there's 4 consecutive consonants. So again, here we see our DGA. We get the dossier on it in terms of what event ID, and if we scroll over, we see the type, it's network activity. So I would say the vast majority of what we see on MISP, on the open source feeds, you've got some hashes in there, but a lot of it is network activity. Extra hops for VLX, there's nothing that scales in terms of being able to monitor or provide surveillance of every single piece of network data that's traversing the wire. And again, here we also report the signing. This takes about 5 minutes to load because it's so big. You can see it's over 61 pages. So I think it's going to be really hard to, I would love to show you the activity going up. It's just going to take a while to load. But here, if you look here, right, you'll see we send the citing in, and now you have activity. If you're sharing with the community, then they can see it. So again, this is another way to get some high fidelity metrics or high fidelity findings. Instead of sending thousands and thousands of logs to your SIM, let's send 1 log to your SIM, so that your SOC analysts aren't parsing through them and doing this DevOps lift to kind of mash up, your .php, your external .phps or your external .exes with a list of bad guys. Here we're doing it in flight, and now literally within 1 second, less than 1 second, you have an absolutely actionable finding. Again, this is John Smith with Extra Hop Networks. Thanks so much for watching.